Now, you probably had an idea that when we're solving systems, that there's a couple different situations that could happen. And I listed three of those situations, or all three of those situations right here. Well, to no one's surprise, we can have a system where the two lines, or the graphs, cross each other. So how many solutions would that system have? You're right. This solution would have one solution. There's only one place where a coordinate pair is a solution to both lines. We also have another situation. We've talked about parallel lines in the past. So how many solutions do parallel lines have? Yeah, none. These lines will never cross each other, so therefore this system has no solution. And then there's a third one, maybe a little bit more hidden that we may not have thought about. We could have a system where one graph is right on top of the other graph. And if that's the case, any solution to one is a solution to the other. So this one has infinitely many solutions. So when we're looking at systems, I want us to be on the lookout for three types of solutions. One solution, no solution, or infinitely many solutions. And I'm going to help you walk through how do we know which one we have. So let's explore this system. Y equals, one equation is y equals 2x minus 1, and the other one is y equals 2x plus 3. So if we look at this system by graphing, let's graph both of these. The first one, y equals 2x minus 1. I have a starting point at negative 1 and a slope of 2, up 2 over 1, up 2 over 1. So there's 1. The other one is 2x plus a 3, so I have a starting spot at 3. Have a slope of 2, up 2 over 1. And it appears that I have a system that has no solution. And that probably should make sense because what have you noticed about our system or about the slopes of each of these lines? Did you notice the slope of one line was 2 and the slope of the other line was a 2? And do you remember that if we have parallel lines, that means their slopes are the same? Or if we have the same slope, it means that they're parallel lines. So we're going to take that idea one step further and look at it in terms of a system, which means that this system has no solution. Another system that I want to share with you, have a system of 2x plus y equals 3, and the other line is 4x plus 2y equals 6. So let's see what we discover if we were to graph both of those. It's not written in slope-intercept form, so it's in standard form. So let's look at their intercepts. If x were 0, y would equal a 3. So that's one intercept. If y were 0, x would be 3 halves. All right, so there's the x and y intercept for the first line. On the second one, if y were 0, x would be 4x equals 6. That would be 3 halves. And then the other intercept, if x were 0, 2 times y equals 6. That would make y equals a 3. And if we were to graph both of those, top one has an intercept of 0 and 3. That's where the y-intercept is at. And then 3 halves and 0. There's one line. And not to anybody's surprise, I was trying to hold off as long as I could without noticing it, but you guys noticed that, wait a minute, those are the exact same x and y intercepts, aren't they? So that tells me then that I have another line right on top of it. So here's an example by graphing of discovering that this system has infinitely many solutions. Now, this doesn't mean that any one particular point, like this point, which is 0 and 3, doesn't really mean that 0 and 3 is a solution to this system, although 0 and 3 satisfies both equations. Rather, every single point along this line satisfies that system, and therefore we can't say it has one solution. We just one significant or unique solution. Therefore, we say it just has infinitely many solutions.